This lesson describes a strategy for balancing skeleton equations that will be classified as neutralization reactions. To recognize a neutralization reaction, one should look at the reactants of the chemical equation. If one reactant begins with the hydrogen ion and the other ends with the hydroxide ion, or OH, this describes a neutralization reaction, and one of the products will always be water. Identifying neutralization by looking for these characteristics will help you employ the strategy that we are about to discuss. The strategy describes splitting the water into the H and OH ions. Because this is a double replacement reaction, when the hydrogen ion and the OH hydroxide ion split free from the original reactants, they form what we know as water. Therefore, underneath water, we're going to write H and OH, and we're not really going to look at the water during the balancing of this particular reaction. This will allow us to look at the H by comparing the H on the reactant side, and the OH by comparing the OH on the reactant side. Independent coefficients in front of H and OH will be obtained. These coefficients should be identical if you have correctly balanced. Let us begin by identifying sodium, or Na, is not balanced. Since there are 3 on the product side, we will need 3 on the reactant side. Therefore, a coefficient of 3 is chosen in front of NaOH. In doing this, this also triples the amount of OH ion, known as hydroxide, and creates 3. We will balance the OH or hydroxide ion on the product side by choosing a 3 in front of the OH that we have split from the water. When we look at the H's that are independent on the reactant side, we see that there are also 3. To balance this, we will come to the product side and place a 3 in front of the independent H's that we have split from the water. You can see that we received the same coefficient for the H and the OH ions. When H and OH join up, they create what we know as a water molecule. Therefore, when 3 of them join up, they create 3 water molecules. This balances the equation by adding or bringing the 3 up to the H2O, the original product called water. We can see the PO4 ion was found on each side, and it was not in parentheses. Therefore, there is 1 PO4 or phosphate ion on both the reactant and product sides. All of the components or ions of this particular reaction are now balanced. This reaction balances with a ratio of 1 to 3 on the reactant side and 3 to 1 on the product side. Let us now look at example 2 and employ the same strategy. Recognize that one of the reactants ends with the OH ion and the other begins with the H ion. This immediately tells us we can take the water product and split it into the H and OH ions for easier balancing. When looking on the product side, we can see that there are 2 nitrate or NO3 ions. However, on the reactant side, there is only 1. The lack of parentheses indicates this. Therefore, a coefficient of 2 will be chosen in front of HNO3. This creates 2 hydrogen ions on the reactant side. To create 2 hydrogen ions on the product side, we will choose coefficient of 2 in front of the H that we have split from the water. We now look at the OH ions on the reactant side and see that there are 2. To balance that, we simply place coefficient of 2 in front of the OH ions we have split from the water on the product side. Again, notice we have obtained the same coefficient in front of the H and the OH. This simply indicates the number of water necessary to balance this reaction. Therefore, bring the 2 up to the water, and the equation is now balanced. This particular reaction balances with a reactant ratio of 1 to 2 and a product ratio also of 1 to 2. Let's employ the same strategy for example C. Again, we will split the water up into the H and OH ions. In looking at each side of the reaction, we can see that there are 2 H's on the reactant side, but only 1 on the product side. Therefore, a coefficient of 2 will be chosen. Likewise, we see that there are 2 OHs or hydroxide on the reactant side and only 1 on the product side. Again, coefficient of 2 will be chosen. In looking at the SO4 or sulfate ion, we can see there is 1 on each side, therefore that is already balanced. Recall when you receive the same coefficient for the H and the OH ions on the product side. This indicates the number of water molecules necessary to balance the equation. This equation balances with 1 coefficient added. Therefore, the ratio of reactants are 1 to 1, and the ratio of products are 1 to 2.